In this lab, we are going to separate two compounds by adjusting the polarity of solvents. The principle in this lab is that polar compounds dissolve in polar solvents, such as water, and nonpolar compounds dissolve in nonpolar solvents, such as diethyl ether.
These are the materials you'll need for this lab. Tear the mass of your weight paper, and then weight 50 milligrams of your ethyl 4-aminobenzoate and another 50 milligrams of your 9-fluoronone. Add your two compounds to your centrifuge tube. Now add 4 milliliters of diethyl ether to your centrifuge tube. Shake so the solids can dissolve.
Place it in the ice bath for 3 to 5 minutes.
Add about 2 milliliters of 3 molar HCl dropwise to your centrifuge tube while swirling. This will protonate our ethyl 4-aminobenzoate so it can make hydrogen bonds and dissolve into the aqueous layer. 2 milliliters of HCl is about the size of your pinky.
Once you have added your acid, invert the test tube to mix the solutions and allow the layers to separate from each other. If the compounds are not dissolved yet, add more acids and shake well until they dissolve.
The separation of the two layers looks like this.
Remove the bottom aqueous layer and place it in a 10 milliliter Erlenmeyer flask.
Repeat these steps 2 more times.
We'll get the 9-fluoronone out of the ether layer still in the tube later, so make sure you put it somewhere safe. Now you will add 6 molar NaOH to the solution until the pH is basic. This will deprotonate ethyl 4-aminobenzoate, causing it to be insoluble in water and precipitate to the bottom. Here you can see that the ethyl 4-aminobenzoate is precipitating out of the solution. To get all the product we can, we will add base until the pH is basic. Check the pH every 15 to 20 drops of base by using a glass stirring rod and letting a drop touch the red litmus paper. Eventually, you will see a blue dot, indicating that your solution is now basic. Once the litmus paper turns blue, cool your solution for 10 to 15 minutes. Now, we are going to set a filtration apparatus to catch our ethyl 4-aminobenzoate solid. You will need the following. This is how your filtration apparatus has to look like. Remember to connect the hose to the vacuum trap in the sink, not to the actual faucet. Start by turning on the water to create a vacuum, and lightly wet the filter paper with distilled water. Now add the aqueous solution to the filter. Remember to rinse your Erlenmeyer flask with distilled water to get the rest of the product and pour it into the filter apparatus. When all the water has been filtered, wash the filter paper with water. Allow your solid ethyl 4-aminobenzoate to dry for 3 to 4 minutes with the water running.
Tear the watch glass and record the mass.
After drying, turn off the water, remove your funnel, and gently slide out the filter paper. Scrape as much of the ethyl 4-aminobenzoate as possible on your teared watch glass. Weight the watch glass and the ethyl 4-aminobenzoate and calculate the percent recovery.
Measure 1 milliliter of water.
Add the water to the organic layer.
Invert the test tube to mix the solution. After washing the organic layer with water, remove the bottom aqueous layer for disposal. Repeat these steps 1 more time.
Tear a 10 milliliter Erlenmeyer flask with a boiling stone and record the mass. Transfer the organic layer to the teared flask.
Add 1 milliliter of diethyl ether to the test tube to wash the sodium sulfate. And then transfer the diethyl ether to the beaker.
Next, you boil the diethyl ether under the hood. The heat doesn't have to be very high.
After boiling, you should have yellow liquid left in the flask, and the boiling doesn't take very long. When a few bubbles show up on the boiling stone and the bottom of the flask is warm to touch, you can finish boiling. After cooling to the room temperature, weight the mass of the flask with the product. Now, we are going to introduce how to use Digimelt to measure melting point. We first put the product into a capillary tube, put the open side down and smash a little bit of the product, and place the capillary tube in the tube topper and press the button next to it. In this video, we are going to use the example of 9-fluoronon. When you set up start and stop temperatures, you need to know the melting point of the compound. You set the start and stop temperatures that are slightly lower and higher than the range. Since 9-fluoronon has the melting point between 80 and 83 degrees Celsius, we're going to set the start temperature at 77 degrees Celsius and the stop temperature at 85 degrees Celsius. First, press the start temperature button and use the up and down buttons to set a start temperature that is slightly lower than the melting point range.
Next, press the ramp rate button. This is how many degrees per minute the temperature is going to increase while melting a compound, so typically you set between 1 and 2.
Then, press the stop temperature button. Use the up and down buttons. Set the stop temperature that is slightly higher than the melting point range.
After you set up all three, press the start-stop button and you will see the preheat light flashing.
Once you see the green ready light flashing, place the capillary tube in one of the three holes. Then press start-stop button to start melting. This is how it should look like inside of the Digimelt. How the look of the substance changes helps you to determine when to record the melting point. You record the range starting the moment when the substance looks wet to the point when the substance is completely melted. Sometimes it's hard to tell when it's wet, but as shown here, it started melting when you see some movements and collapse inside. And this is how it looks like when the substance is completely melted. After melting the substance, don't forget to press the start-stop button again to cool the Digimelt.